given. I changed the numbers here, but I will go through the steps you would use to solve. It says a utility worker is installing a 34-foot pole, AB. So the length of this side of this triangle is 34. At the foot of a hill, 2 guy wires, AC and AD, will help keep the pole vertical. To the nearest inch, what is the length of AC? So we want to know the length of this guy wire from A to C. Notice there I have a right triangle, okay? And for that right triangle, I've been given an angle, all right? And I'm trying to find the length of this side. Now, is that side the opposite side, the adjacent side, or the hypotenuse for my 54-degree angle? I can't use Pythagorean theorem here again because I only know one side. This is the side I'm trying to find. Okay, so let's take a look. What are we going to use, sine, cosine, or tangent? Well, for our angle 54, we have the opposite side, and we are looking for the hypotenuse. So does sine, cosine, or tangent use opposite and hypotenuse? Hopefully you said sine. We know that the sine of an angle is equal to the opposite leg over the hypotenuse. So that's what we'll use because that's the information we have. We write our specific equation down with our information. Sine of the angle, what's the angle? It's 54 degrees. Equals the opposite side, 34, over the hypotenuse, x. Now we need to solve this equation for x. We go one step at a time. First thing, if x is in the bottom of the fraction, the first thing you have to do is multiply by x on both sides so that you can get it out of the denominator of the fraction. And that leaves you with x times the sine of 54 is equal to 34. My next order of business is to get x by itself. Well, right now it's multiplied by the sine of 54, so I do the opposite and divide by sine 54. Whatever you do on one side, you have to do on the other. So my answer for x is going to be whatever 34 divided by the sine of 54 is. Now you can use your calculator. You can put it all in your calculator as long as you use parentheses. So you can do 34 divided by, but here you want parentheses. The sine of 54, so I'd put 54, remember, and then push sine and put my end parenthesis on, equals. And when I do that, I get about 42.02. It wants it to the nearest inch, but this would probably round off to just 42 feet. If you're not comfortable with the parentheses in the calculator, you can calculate your answer this way. Also, you can find out what the sine of 54 is, so put 54 and hit sine, and you'll see that it's 0.80901, and then put in your calculator 34 divided by that number. You might be off a little bit because of the rounding, but we still get close to the correct answer. Okay, there is a second part to the project. There's a second part to the question. It said AD is perpendicular to the hill. And notice they marked that. Here's our line AD. It makes a right angle with the hill right there, which makes an angle of 32 degrees with a horizontal line. Now, what they mean by that is that our hill makes an angle of 32 degrees with the flat ground here. So this angle right here is 32 degrees. That is what they are saying. To the nearest inch, how long should the guy wire be? Now, what's the guy wire? On this side, the guy wire here from A to D. That's what they're asking for. Well, let's go back to that last page. I don't remember what the height of our pole. Oh, it's a 34-foot pole. Okay, so this is still 34. Notice again I have a right triangle here. Problem is I don't know the measure of any of the angles. I know an angle here, but not here. What I'm going to do is say, well, look, the pole and the floor here make a 90-degree angle. If this part's 32, this part would be whatever is left over. So I'm going to go 90 minus 32 to find the remaining amount that's left there. And that would make this angle 58 degrees. And notice when I put these two together, they do add to be 90. And the reason for that is because together they make a right angle right there. The pole is at a 90-degree angle to the flat ground. Okay, so now I have an angle. I'm going to outline my triangle I'm working with in blue, just to give us a better look of exactly what we're looking at in this picture. Okay, we're working with a right triangle. We are trying to find this side. We know that this side here is 34, and we know we have a 58-degree angle here. Our first job is to find out what do we need to use, sine, cosine, or tangent. Here is our angle. What parts do we have? We have the opposite side is what we're looking for, and here is our hypotenuse. Here's our right angle. Across from that is the hypotenuse. So we're working with hypotenuse and the opposite side. What uses opposite and hypotenuse? Is it sine, cosine, or tangent? Well, hopefully you took a look in your notes and you find out that the sine of an angle is opposite over hypotenuse. So that's what we'll have to use because those are the parts we're working with. We write down our equation. Sine of the angle, what's the measure of our angle? 58 equals the opposite side, x, over our hypotenuse, which was 34 this time. We want to solve that. So let's go ahead and solve. How are we going to get x by itself? Well, x is divided by 34. Notice it's in the top of the fraction this time, so we don't need to multiply to get it out of the bottom because it's not in the bottom. All we have to do is multiply both sides by 34 so that it can be by itself. Okay, and I get x is 34 times the sine of 58. I take out my calculator, calculate that. You want to do the sine of 58 first. So you put your angle 58, push your sine button, multiply by 34. When I do that, I get about 28.8. It wanted it rounded to the nearest inch. Okay, which in decimal form is more difficult to do. What you can do is you can say, okay, I have 28 feet. I'm going to subtract the 28 whole feet. So I have 28 feet and 0.8 parts of a foot. Well, how many inches are in a foot? There are 12. So if I take just that part, that decimal, times 12, it will tell me how many inches I have. So it looks like it's 28 feet and 10 inches. Okay, so notice it's not 28 feet 8 inches. The 0.8 doesn't mean 8 inches, it means 8/10 of a foot, and there's 12 feet in an inch. Okay, or 12 inches in a foot, sorry. So we take that 0.8 times 12 inches to find out how many inches we're working with.